yesterday. I said you could verify this on your calculator because your calculator only does restricted domain. But I need to see your restricted domain in terms of where your triangle falls. So the first one, sine is restricted to 1 and 4. It is positive in 1, so that's what I'm expecting to see. And your angle, I didn't say radians or degrees, so whatever you gave it to me in is fine. Your cosine, your arc sine of 0, again, you're from here to here. It always does this on me, yes. From here to here. So where is the y value? 0, right here. That's what I would expect to see on your paper. I know you can put it in your calculator. You can verify it in your calculator. But you have to be able to do this without your calculator.
So you just want us to draw a circle?
Basically, drop your triangles, whatever it is you need to do. If there's the quadrant angles, just go like this. Where is y1? And there's my answer.
Okay.
Our cosine goes from here to here. Quadrants 1 and 2. Where is my cosine 1? Right there. That's what I would expect to see. If I give you this test and it says no calculator, you're going to have to do this. You're not going to have your calculator at your disposal. No, because yesterday I went through how to find this. So again, unrationalize this guy, and everybody's positive in quadrant 1. So you really only have to think about the negatives. This is your special triangle. This is your 30 degrees, if you gave me 30 degrees. Arctan negative 1, this is your 45 degree. Tangent is positive in 1, negative in 4. And remember, your domain goes from negative pi over 2 to positive pi over 2. So therefore, we can't use these guys. And your angle cannot be 315. It's out of my domain. It has to go to the negative part. It has to be negative pi over 4 or negative 45. Number 11, tan is negative in 4. And I gave you almost the same thing. Tan is positive in 1. So you can see they're the same triangles, right? But restricted to different quadrants. Anybody have a question on any of these? Finding your restrictions. No? I also have a little sheet that might help.
Wait, there's more questions.
No, I know that.
Oh, okay.
I know. I just remembered. I just took out the sheet. I have a little sheet that will give you the inverses. Because these are inverses, your domain is the range of your original function. So if you kind of look at the ranges, you'll see where your restricted domain was. These are the inverses. I don't think these printed out on the other sheet that I gave you with all of the stuff on it. I took it out and I wanted to give it to you.
These the inverses of just the regular?
Yeah, we only do the 3. We don't do reciprocals. Just the 3, basically.
Oh, good. Okay.
No, this. Okay, now, we can say arc sine, we can say sine negative 1. So sine is positive in quadrant 1. Drop your triangle and give me your angle. Tangent is negative in quadrant 4. Drop your triangle, give me your angle. Now, this guy just went off the inverse curve. These are your inverse curves. So remember we talked about the angle, and we swapped, it's the reflection over the line, y equals x. So therefore, you always have to swap these out. These are your inverse curves. Arctan, arccosine, arcsine. They're your inverse curves. They swapped out the numbers. So if you think about it, it's almost like a reverse look here. So it would have been pi over 4. What is the tangent for pi over 4? 1.
Oh, okay.
And they swapped it out because this is the inverse curve. So maybe if you kind of just re-swap it in your mind, like if I do this, who had a tangent of negative radical 3? Maybe that would kind of help you out a little bit. So where is your tangent negative? In quadrant 4. So draw this out in quadrant 4. and find your angle. It's the reverse. It's the inverse curve. So the inverse swaps it out. So just do it in reverse. So say this to yourself. What angle has a restricted domain? My restricted domain has a tangent of negative radical 3. Oh, negative radical 3 has to be in quadrant 4. So drop your triangle in quadrant 4. Tangent is y over x. What angle is this? 60. But remember, it goes here to here, so this would be negative 60 degrees. So this in terms of radians would be negative pi over 3. Because this is on the inverse curve, it's already swapped out. Just kind of think in reverse. So I like this example because it does show your inverse curve, which is our goal to be doing this. When I want a tangent who's negative, he's in quadrant 4, and this is a 30-degree angle. So here's my 30-degree angle. Label my triangle. What's the tangent? The tangent is y over x. That's what goes right in here. That's a negative 30 degrees has a tangent of negative 1 over radical 3. It's just swapped out because this is the inverse curve. And they did the same thing with cosine. If you think about it, what angle in quadrant 2 has a cosine of negative 1/2? So negative is in quadrant 2, x over r. There's this angle. It comes all the way like this. If you gave me 120, notice they did theirs in all radians. So there's 2 pi over 3. It's the same as your 120. It's just another way of saying what quadrant is this in. And if it's negative, it's either going to be in the tangent and sine are in 4, cosine's in 2. And everybody's positive in 1.
So when you use the special right triangle, so like for number 17, you figure out that like for the tangent of negative pi over 6 is negative 1 over the square root of 3, would you just say that like, then you would just say, so x would be,
That would be your x. Because they originally
1 over
on your...
square root of 3?
Yes.
That's an angle?
No. That's a value. These are reversed, remember? Remember my tangent curve goes like this. So if I picked a value down here, if this angle was negative pi over 6, just say this is negative pi over 6, this guy would be negative 1 over radical 3, right? So your point would be negative pi over 6, negative 1 over radical 3. When you do an inverse, you interchange those two. That's why they're interchanged. This is the inverse curve.
Oh, so
You're working on the inverse curve.
oh, I see, because I was confused because they have radians as the y and then...
Yes, because they interchange your x and your y.
I got it now. I keep forgetting that.
That's why I did like this, because you're actually working off your inverse curve, and your inverse tells you, oh, interchange your x and your y. But the same thing happens. Look, they're positive here, they're negative here. They're positive here, they're negative here. So you're still dealing with two restricted quadrants. Does that make a little bit more sense?
I was thinking, yeah, I get it now.
Get it? These the last two? Figuring out where your restrictions are, figuring out what it's asking for. So, my first part here, it says arctan negative 5. What does it want me to look for? What does arctan mean?
Tangent inverse.
It means an angle whose tangent is negative 5. So, and then once we find where that angle is, what do we want to find?
The tangent.
It's tangent. So let's just, it would be negative 5. Very good. Very good. You got the trick right off the bat. But let's say we didn't see what Sarah saw. That was very good, Sarah. So, my tangent is restricted to where, Keanu? 1 and 4. So where would I find it negative?
4.
In 4. I drop a triangle in 4. I say tangent is y over x. And I could do this if I wanted to, but all I need to do is find my tangent of this angle. I don't care what the angle is. I just needed to locate it So my tangent is y over x, which would give me -5 over 1, or -5. And Sarah caught the trick right away. These kind of canceled each other out and gave us a tangent. This is key. This is the final thing that you want to find. This is the final thing. So if you only need to find one of the functions, don't find the angle. Place it, and then work from there. That was good. Okay, now this one's a little different. This one says, what does that piece say?
Sine is 5 pi over 3.
Okay,
Or the sine of.
the sine of 5 pi over 3. Now, and then once I find the sine of 5 pi over 3, I'm going to put it in here, right?
Yeah.
And then I'm going to find an angle who has that sine. So do one step at a time. This is asking me to find the sine of 5 pi over 3. Just cover this. You've done this before.
Yeah.
Where is 5 pi over 3? This is 3 pi over 3. This is 6 pi over 3.
It's 1 below.
It's 1 below. So the sine, and what angle is this? 60. They don't always work out that it works in the restricted domain, so you just got to worry about where it goes. So what is the sign here? I'm going to replace this. The sign is what? But is it positive or negative? Negative. So now I want an angle whose sign, restricted angle, whose sign is this. I so happen to be in quadrant 4. But how do I name this angle now as a restriction? My domain goes from -pi over 2 to +pi over 2. I can't call it 5 pi over 3. This tells me restricted domain. So it's the same angle, I get it, but how do I name that angle within this domain?
You have to say -60.
And -pi over 3.
Oh, sorry. I didn't know we were doing it in radians.
Now, it could have said this. It could have said this. Where is this angle located?
Second quadrant.
Second quadrant. It would still be the same setup, right? Now my sign in the second quadrant would be positive. Then I would want to find a restricted angle whose sign is now positive. And what quadrant would this one be in? 1. So I don't really have to drop my triangle. I just have to know that take this angle and put it here. So this guy would be pi over 6. Oh, sorry, pi over 3.
Yeah. Wait, so it only, so like for sine on the inside of parentheses, if say it had landed, say it was like 4 pi over 3. You could still drop your triangle there as long as it's not
Because
arc sine.
this is not restricted at all, is it?
It's not an inverse.
Not an inverse. And then
Okay.
I would put it here, and then I would say, oh, now it's negative. And then I would do this. Where is it restricted?
Okay.
Negative.
So only when it's an inverse, it's restricted.
Right. Work from the innermost parentheses, start at the right. Always your composition, start at the right. Resolve that part first. And then work your way and see what they're asking on the left side. Okay, you guys? Don't try that one. I'll go back to that. That's a trick in there. Try this.
Wait.
We'll go back to that in a minute. It's a dumb one for you to have to place. So, I mean, it's something that happens, but I'd rather you do this. Where is everybody positive?
First quadrant.
1. So I want you to locate that, but what answer do I want? Do I want an angle or do I want a ratio?
You want an angle.
What am I asking for? The tangent of this thing. I want a ratio.
Sorry.
So is it 2 or 3?
What do you get?
That's square root of 5 over 2.
Okay, so let's see. So you put it here, and you said this is x over r. So 9 square root of 5. So you got the tangent is radical 5 over 2.
This makes more sense than this.
But that's exactly what you did. But you had to do this first. Okay, do the next one.
Wait. Okay. So, but don't you have to put the square root of 5 over 2 in the parentheses?
No,
It would be,
you found, this is asking for what angle has a cosine, a restricted cosine of 2 over 3. So I located this. This is my angle that has a cosine of 2 over 3.
okay.
Then, once I find that angle, I say, give me the tangent of that angle. Because
Oh, so
remember,
you don't
compositions go left.
You just have to find where it is.
Sometimes you have to find the angle if it's out here. Sometimes you just have to find the ratio. But remember, where do your compositions start? They start at the right and they go to the left.
So it just depends on whether or not
Depends on what
it's
it's asking.
yeah.
So this guy here, I start at the right. What is it asking me to do? Find an angle whose sine is, restricted sine is negative 3 over 5. Where is sine restricted negative? 4. So I label, excuse me, y over r. What's my missing part? 4. Okay, so now I located my angle. It's here. I look to my left. I roll that into my left. It's a composition. And I only want the cosine. So what's the cosine of this thing? 4 over 5. See it?
So would you just say like cosine equals 4 over
The
5?
whole thing equals 4 over 5.
Oh, so you have to put the whole
Well, no, just say equal to 4 over 5.
Okay.
Okay?
Are we going back to the tricky one?
Yeah, let's go back to the funny one. Okay.
I don't think we're gonna find this very funny.
You'll find it easy. I want an angle, cosine negative 1 says, give me an angle whose cosine is pi.
180.
Pi is 180, but I want the angle, so what is pi in terms of numbers? 3.14. So give me an angle whose cosine is 3.14 first.
180. Negative 180.
I want to cosine. Let's draw your cosine first.
I'm confused as to what you're asking.
I know that's why I didn't want to give you this one. What's the range of cosine?
Negative 1 to 1.
Negative 1 to 1, there's no answer. Do we have an angle whose cosine is greater than 1 or less than negative 1?
Oh, that's sneaky.
So this one's no solution. So that's why I didn't want to give you that one.
I thought you were saying something that's not